I am back. Gee, aren't you getting bored of me yet? I don't know. Maybe I should I should put my glasses on, and then on, off. That's the trademark, right? I don't sip cups of coffee every time that I start a video. I should though, because my voice is getting dry. I'm going to put a pause in here. Isn't that magic? All of a sudden, a glass of ice water appears in my hand. Gee, I feel like Mr. Potter, Harry Potter. I'm no longer Indiana Jones. I'm Harry Potter. And I mean, we can make this a simultaneous sip of water. Scott Adams is much better at it than I am. I can only say, go. Smoothes my throat and maybe improves my voice. So here's another mechanism of sediment transportation by wind. Usually the particles transported by wind, also weathered from mountains or reworked from other older sediments, are the finer grained stuff. And we'll talk about the grain size of sediments later on, but now say that this is a lot finer than the stuff that initially got eroded off in the mountains, right? Started with boulders, and then the boulders get broken down and becomes gravel, and then the gravel gets broken down and becomes sand, coarse sand, medium sand, fine grained sand, silt, and another grain size is clay, which is 5 microns or smaller in size. Well, the smaller fraction of this grain size scale that I just gave you, and is called sometimes the Wentworth scale, and we'll get back to that, so don't start writing down like crazy all these terms. We'll get you familiar with them sooner or later. I never know with the camera how to wipe that hair out of my eyes. Next week I'm going to get a haircut, by the way. Anyway, back to Aeolian deposits. So the finer fraction of the clastic sediments are small enough and light enough, therefore, to be picked up by the wind and transported until the wind strength, the flow of the wind, so to speak, decreases, and then the sediments fall out. And they can form Aeolian dunes in the deserts, or Aeolian dunes on the beaches, behind the beaches, on shorelines of seas, and also of large lakes. Lakes can have shorelines and dunes, right? Aeolian dunes. So that is another way of forming rock. So by now, you're getting this feeling that you understand that how rocks are being formed. It's quite an intricate system. I mean, you start at the mid-oceanic ridge, and then you get the ocean crust that is heavy minerals, dark-colored minerals, forming basalts, lava basalts, right? And they cool off and get heavier and heavier and may fall back into the mantle. And there you have here a continent, which is often created by the erosion of rocks, maybe volcanoes that come to the surface through the continent, and I'll talk about it in a second, and then get eroded. The heaviest minerals fall out near the source, and the further away you get, the lighter and lighter the mineral content is, right? Not only in density, but also in color, because silicas and feldspars and all these other minerals that are left over from this erosional process, right, are all light in color. We call those silica-rich rocks sometimes acidic rocks. Acidic rocks. So here we have a subduction zone, and it dies below the continent or below an old ocean crust, but not as old as the one that is descending. And guess what? There's a lot of friction involved here at the edge, at the subduction zone. And so the temperature increases not only because it falls down into the mantle, but also because of friction. And it can get so hot that the rocks that were crushed first start to melt again and form a magma, like here, that rises up back to the surface and sometimes intrudes into the overlying rocks, right? You have intrusive rocks, also known as plutonic rocks, right? And they are often higher in silica content, okay, because they molten combination of ocean crust and continental crust. So they are often a lot richer in silica and are more acidic. You get the message? So these magmas that are penetrating the crust, right, they of course cool down unless they, through a pipe or vein, reach the surface where they form volcanoes, like we see in the Andes and also in the Rocky Mountains in Washington, like Mount St. Helens. These volcanoes are formed near a subduction zone. And when you have a continent colliding with the subduction zone, right, the first thing that you do is, if you have colliding continents, you're creating mountains. And mountains are a thickening of the crust. And remember this, the process of isostasy with glacial isostasy. Who invents these terms? Anyway, the thickening of the crust is again, in this case, like a cork. And so the rock near the continents that are compressed by the tectonic forces of colliding, or compressional tectonic forces by colliding continents. You get a lot of terminology here right now. So you have colliding continents of rock that compresses against each other, right? And then, of course, when it compresses, it thickens. It thickens. I shouldn't put this right in front of my mouth, then you can't hear what I say. The continents collide and crush each other, compressional tectonics, and the crust thickens. And it's the cork principle again, because the crust is lighter than the underlying mantle. It thickens, so part of the cork rises and part of the cork crust sinks into the underlying mantle, creates a mountain, or at least an uplifted belt of a bulge of materials with a root, as we call that, extending into the mantle, much deeper than the regular crust. You see that here. It is thickening and it lies much deeper into the gray-colored mantle. Well, these are the roots of a mountain chain, like the Andes or the Rocky Mountains, and this is a bulging area with here and there a volcano sticking out above it. It doesn't look even close to mountains, because you have to realize that it takes erosion by water cutting steep valleys, because the water wants to reach ultimately sea level, and it has erosive power. And the ice, the glaciation, ice caps are even worse. So it takes another few thousand years for the ice and the water to cut out the topography, to sculpt out the topography of the mountains as they are today. Right. So now you have an idea. that when you were driving, say, from Calgary into the mountains, you were just having a smooth slope, right? You started here in the plains of Calgary, and then you drove up to the bulge until you were reaching the highest point. But you may not notice it because it can be so gradual. It's only the sculpting of the ice and the water that creates those sensational landscapes that we call mountains. Hey, hey. Okay, we're reaching another point. So the magmas that cool off, right, they form granites and granodiorites, and that's based on the composition of the magma, how much silica is in it, how high is the silica compared to dark minerals, right? And we'll talk about that later on. But also the surrounding sediments that have now been compressed and contorted, they also heated up by the magma, and they start to partially melt and recrystallize if once the magma starts to cool off. And so the rocks have been metamorphosed into what they will be after all that heating and pressure that has been pushing on them. So that is another type of rock we call metamorphic rocks. And with that, we're going to have a break.